Okay, we're in section 3.2 today, solving equations having like terms in parentheses. Like terms mean that you can simplify, you can combine something before you solve, before you move it to the other side of the equation. And you're going to see distributive property today. The first thing I want to do is I want to turn in our books to page 127. Page 125. Page 125 in our books. I want to read an example at the top of that page. Your school's basketball team is playing in the championship game. For the game, the cheerleaders want to buy a banner that costs $47. They also want to buy small items to give the students. Pom-poms are $5.20. Noisemakers are 80 cents. The cheerleaders have a total budget of $377 for the game. Okay, so they buy an equal number of pom-poms and noisemakers. How many can they afford to buy? What did I tell you yesterday is the very first thing that we start with when we're writing an equation? What do you start with? An equal sign. Okay, so even if you're clueless, you should still at least have an equal sign on your paper. Okay, now the equal sign obviously separates both sides of my equation. Now on one side, what goes there? Doesn't even require any math. What goes on one side? The total, the answer. Okay, so the total goes on one side. What is my total? $377. That goes on one side. Okay, now on the other side, I know I'm going to have a variable and some operations. Well, when I'm saying total, what operation is that? Subtraction? No, it's addition. Okay, is there any number in here that will not be affected by how many of something is bought? The banner. The banner, right? How much is the banner? $47. Is that affected by anything else? No, the banner is just $47. So that number stands alone. That number has no variable because it's not affected by any of the quantities. All right? But what is? The pom-poms, right? The pom-poms are $5.20, but do I know how many I can buy? No, so there's my variable. Now, the noisemakers are 80 cents, but do I know how many I can buy? No. So there's my variable. So here I have, now I'm buying the same quantity, right? It says I want to buy the same number of each, so that's why I can use the same variable for each one of those. Does that make sense? Since I want to buy the same number, whatever my answer is will be the same number of noisemakers and the same number of pom-poms. So now, do you see something that you could simplify on that side of the equation? What can you simplify? The variables. 5.2 plus 0.8 is 6. Okay, and now I can just solve it like a regular two-step equation. What do I do first? Subtract 47. Both sides. 6x equals 330. Divide both sides by 6. X is 55, and I abbreviated noisemakers and pom-poms. All right, now in example 2, what do you see right off the bat? What do you see? Parentheses, which I call the distributive property. So the very first thing I need to do is I need to get rid of my parentheses. I need to distribute the 7. 7 times 3 is what? 21. 7 times negative x? Negative 7x. Remember, there's that understood 1 in front of the x. Okay, so negative 7x. Now that I've gotten rid of my parentheses, now I can solve it like a regular two-step equation. I want to give you a minute just to go ahead and finish solving. Now, subtract 21 from both sides. Negative 42 equals negative 7x. Divide both sides by negative 7, and x equals what? 6. Very good. All right, now I want you to try the second one. Has anybody already done it? No? Okay. All right, go ahead and try the second one. Start to finish. Okay, so distribute. Negative 36 equals 6 minus 3x. Now I subtract 6 from both sides, divide both sides by negative 3, and I get 14. Who got 14? Who got 14? Good job, guys. Awesome. Any questions? Any questions at all? Anything? Do you see where you went wrong if you missed it? Maybe just a small little error. All right, one more example. In example 3, now I'm combining like terms after distributing, okay? So it's kind of like one more step, okay? So I've got 5 minus 2 times x minus 1 equals 8. So very first thing I do is I have to distribute. Now let me ask you this. Is it 2 times x or is it negative 2 times x? It's negative 2. I can't ignore that sign in front of the 2. Okay, so 5x minus 2x plus or minus 2? Plus 2. Negative 2 times negative 1 is a positive 2 equals 8. But now I still can't solve, and here's where it's very important for you to simplify everything before you start moving numbers. Okay, what else can I simplify? Hayden, turn around. 5x and negative 2x to make 3x. 3x plus 2 equals 8. Subtract 2 from both sides, and now I just solve it like a regular two-step equation. All right? So I want you to go ahead and try the second one once you're done copying that down. All right, so here we go. So now we distribute first, 4b plus 20. Then we combine our like terms, 12b plus 20. We subtract 20. 12b equals 24. Divide both sides. b equals 2. Who got it right? All right, awesome. Okay, one more thing I want to cover. You have a couple of perimeter problems. On your homework tonight, you have a couple of perimeter problems, okay? So I want you to go ahead and you don't necessarily have to draw the shape, but I want you to make the substitutions into the formula. So you know the length and the width and the perimeter. I want you to make your substitutions. Okay, so I make my substitutions. I distribute and simplify. And then I solve my two-step equation, x equals 11. Did you get it? 11. All right. Quiet, please. Okay, so you have 2 of these on your homework tonight. What if it's a triangle? What's my formula? Yes, it is a plus b plus c. Just add them together and then solve for the side that you don't know. All right, if you understand that, that's everything you need to know for 3.2.